Hello students, in last lecture we have seen the definition for transient response specifications. So there we have seen the definition for TR, TP, MP, TS, ESS. Okay, so now we will derive the formulas, okay, for that specifications. Now see, first of all, expression for rise time TR. Expression for rise time TR. Okay. So what is expression for rise time TR? As per definition, we have seen that time required to reach the output response. Time required to reach the output response to 0 to 100% of the output, that is final value. Okay, 0 to 100% of the final value. Okay, we have seen for underdamped response we have taken that C of t to be 100%. Okay, so here I have assumed that C of t is equal to 1 because we are deriving expression for TR. Okay, please remember, while deriving the formulas for all these specification, we are using this basic formula of C of t. Okay, what is this C of t? C of t is nothing but output response for underdamped system, or I will say output response for second order underdamped system with unit step input. Okay, we have derived this expression and I told you to remember this expression. So C of t is equal to 1 minus e to the power minus zeta omega nt upon under root of 1 minus zeta square sine omega dt plus phi. So this is our expression. Now what we will do, as per definition of rise time TR, I will substitute C of t is equal to 1. So look at this, I have substituted here C of t is equal to 1. Okay, so right hand side will be as it is, I have substituted here 1. So 1 minus 1, it will be 0. Okay, so I have written this expression as, look at this, e to the power minus zeta omega nt upon 1 minus zeta square, this term sine omega dt. Okay, so I have written omega d, I have replaced with the formula omega n under root of 1 minus zeta square t plus phi is equal to 0. Okay, because we know that, see here we have two parts, exponential part and sinusoidal part. So exponential part cannot be 0. So definitely this sinusoidal part will be 0. So what I did here, sine omega d, this is nothing but omega d. Okay, I have substituted the formula of omega d. So sine omega n under root of 1 minus zeta square t plus phi, and we have this right hand side that is 0. So sine pi is 0. Okay, sine pi is 0. So now I am comparing left hand side and right hand side. So I will get the expression for TR. So this T is nothing but TR. Okay, so TR is nothing but rise time. So I got the formula for TR. So this is formula TR is equal to, look at this, this will be pi, then we will shift this phi here, so pi minus phi upon omega d. Okay, so this will be TR is equal to pi minus phi by omega d, or you can substitute the omega d as omega n under root of 1 minus zeta square. Okay, so this is the expression for rise time TR. I told you that this can be asked for deriving. Then next we will see expression for peak time TP. Okay, see, when we are deriving the expression, actually we are deriving the formulas for all these time response specifications, that is TR, TP. Okay, so first of all you have to remember all that definition we have seen in last lecture. Okay, so just now we have seen for rise time TR, now we will see for peak time TP. Okay, so what is peak time TP? We have seen that the time required for output response to reach to the maximum value. Time required for the output response to reach to the maximum value. So when I am saying the maximum value, I am considering the first peak overshoot. Okay, so here for getting the maximum output, we know that I need to consider this dC of t by dt is equal to 0. Or I will say, when the derivative of this C of t will be 0, then only I will get a maximum value. Okay, so see, again I am using this same term here, that is C of t is equal to, what is this? This is nothing but the output derivation or expression for the output response. Same I have used here. Okay, I have written C of t expression here also. So C of t, please remember, C of t is equal to 1 minus e to the power minus zeta omega n t upon under root of 1 minus zeta square sine omega dt plus phi. Okay, so see what I will do here, as I need the expression for peak time Tp. How I will derive expression for Tp? When I will differentiate this expression with respect to t, okay, then only I can derive Tp. So what I did here, look at this, this is expression for C of t. So I have rearranged that expression, because you can see that in this expression we have two terms, that is exponential term and this sinusoidal term. Okay, so we know the formula for differentiation, that is first derivative of second plus second derivative of first. Okay, so we have these two terms, so I have rearranged this expression. Okay, so I have taken that exponential part inside. Okay, and we know that it will be always easy to differentiate the exponential part. So what I did, I have taken first as a sinusoidal, second as a exponential. So look at this. Here I will differentiate with respect to t. I will differentiate C of t with respect to t. But I know that dc of t by dt is equal to 0 after differentiation. So here dc of t by dt I have substituted as 0 here. Okay. Now see what I will do. I will derive this expression. So what I did, I have taken first term as sinusoidal, second term as exponential. So look at this, first derivative of second. Okay, so when you will differentiate this exponential, it will be as it is, and minus zeta omega n, it will be minus zeta omega n. Okay, so first derivative of second plus second derivative of first. So derivative of sine, it will be cos omega dt plus phi. Okay, into omega d. So I have differentiated this expression. Okay, now look at this. What I will do here, I am equating this right hand side with respect to 0. So this part will be definitely 0. Okay, so I have rearranged this formula. Look at this. Here there is a term minus zeta omega n. So I am taking this part on left hand side. So this part will be, look at this, zeta omega n e to the power minus zeta omega n t sine omega dt plus phi as it is. Okay, this term will be on right hand side, cos omega dt plus phi. Okay, look at this, this is actually omega d e to the power minus zeta omega n t. Okay, so you can see that I have rearranged that step. Okay, now what I will do, you can check that here e to the power minus zeta omega n t, e to the power minus zeta omega n t, it will get cancelled. Okay, one more thing is that here omega d part is there. So we know that I can replace omega d with omega n under root of 1 minus zeta square. Okay, so if I will replace this omega d, so you can check that this omega n and this omega n will get cancelled. So what will be left on right hand side? So this omega d will be replaced with under root of 1 minus zeta square. Okay, so now look at this step carefully. Okay, I have cancelled out the common terms, omega n e to the power minus zeta omega n t. This omega d, now only this part is left because omega n will get cancelled. Okay, so look at this. Now here I have substituted the formula for zeta and under root of 1 minus zeta square. Look at this. This is actually zeta triangle. While deriving the expression for output response, we have seen this zeta triangle. So what is that zeta triangle? We know that here actually cos phi is zeta and sin phi is under root of 1 minus zeta square. Okay, so what I did here, look at this, I have replaced that zeta with cos phi. Okay, and I am replacing this under root of 1 minus zeta square with sin phi. Okay, so I hope you got the concept. Okay, so cos phi, this sin omega dt plus phi, it will be as it is. Cos omega dt plus phi, it will be as it is. Okay, I have replaced this term sin phi. Now you can check that here this expression is in the form of sin a minus b. Okay, we know the formula for sin a minus b. So this is actually a, sin a minus b, it will be sin a cos b minus cos a sin b. So we know this formula. So what I did here, I have substituted that value because sin a minus b. So this is a. Okay, So this is nothing but sine A, and B is actually the phi. Okay, so on right hand side again 0 will be there. Okay, so we know that sine pi will be 0, so I have replaced that 0 with sine pi. Then finally I got the expression for TP. So peak time TP is given by pi minus omega d. Okay, you can substitute the formula for omega d as omega in under root of 1 minus zeta square. So this is expression for peak time TP. Okay, so in this lecture we have derived two formulas, rise time TR and peak time TP, from the basic definitions. Okay, so I hope you got the formula for TR and TP. Thank you, students.